Hi, I'm Jared, and in this video I'm going to talk about the various tasks available in the Eprep software. I'm going to group these tasks into three categories, and these are tasks for standards preparation, tasks for sample preparation, and then tasks for mixing. Some of the tasks are suitable for both standards and sample preparation, like the Add Internal Standard task, and I'll cover these only once in the standards preparation section. I'll give a short description to explain the task, and then for the more complex tasks, provide you with an example. So let's get on with it. The first task which we will cover is the Add Diluent task, and this task adds a defined volume of a solution or solvent from a single input vial or vial group to a series of output vials. This task is commonly used as a starting task, especially if preparation is into an autosampler vial. By adding a defined volume to all output vials, say 300 microliters, for all the subsequent steps, the needle is dipped below the level of the diluent, providing complete transfer of liquid from the syringe. This is good practice also because the transferred amount is not deposited directly onto the glass surface of the container, and this could cause loss through absorption or volatilization. The first standard preparation we shall cover is probably the most used, and this is the serial dispense task. To prepare working standards in the range 10 to 50 parts per million for 5 vials from a stock standard with a concentration of 100 ppm, the starting dispense volume would be 100 microliters, and then the volume increment would also be 100 microliters. This task would typically be followed by making the solution up to a defined volume. In this example, let's say that the final volume is 1 ml. So the first vial would receive 100 microliters from a 100 ppm stock standard solution, resulting in a final concentration of 10 parts per million. For the second vial, a 100 microliter increment of the starting volume would result in 200 microliters of the stock standard dispensed, giving a final standard concentration of 20 ppm. And following on with the 100 microliter increment, the concentrations in the next 3 vials would be 30, 40, and 50 ppm. An advantage of the serial dispense is the workflow for the preparation of standards is very robust. So if the number of output vials increases from 5 to 8, the working range would automatically extend from a range of 10 to 50 ppm now to a range of 10 to 80 ppm. The volumes associated with the task would not need to be edited. The variable dispense task dispenses a reagent from a single input vial or vial group to a series of vials where a specific and different volume can be dispensed to each unique output vial. This task is very useful if you want to create a series of working calibration standards prepared from a stock standard where there is not a constant increment volume between the vials. The volume of stock standard for each vial is entered into the software. So, for example, for the preparation of 5 vials of working standards such as 10, 15, 20, 30, and 40 ppm, the following parameters would be set. if the stock standard concentration is 100 ppm and we set the variable dispense volume for the first vial to 100 microliters, and then this vial is made up to a volume of 1 ml, the first vial concentration will be 100 over 1000 by 100 ppm, which is 10 ppm. For the second vial, if we set the variable dispense volume now to 150 microliters, the final concentration in this second vial will be 15 ppm, and so on for the other vials, as you can see here. So the adjustable parameter for the variable dispense task is the dispense volume, which is set individually for each vial in the output group. The serial dilution task can be used for making up an exponentially decaying set of calibration standards. For example, a series of vials should be preloaded with a solvent solution using AddReagent. A defined volume of a reagent or standard is dispensed from an input tube to the first vial in the series. The same volume is then aspirated from this vial and transferred to the next output vial in the series. From the second vial, the same defined volume is then transferred to the third vial in the series and continues down the defined number of output vials. It is very common to include a mixing step after the volume addition to ensure the vial contents are thoroughly mixed before aspiration of an aliquot for the next step. The vortex mixer is commonly used for this purpose. An example of this is as follows. If the stock standard is 1000 ppm and a 100 microliter aliquot is taken from this stock and transferred to a vial already containing 900 microliters of diluent, the concentration of this first vial will now be 100 ppm. This process is continued for the second vial, where 100 microliters of the solution from the first vial is taken and dispensed to the second vial, resulting now in the concentration in the second vial of 10 ppm. And the process continues for as many output vials as there are in the output group. The Add Internal Standard task adds a defined volume of an internal standard solution from a single input vial or vial group to a series of output vials. A common example of this is the addition of an internal standard aliquot to a series of working calibration standards or a set of sample vials, and then the vials could be made up to volume. The batch many-to-many task will take aliquots from each of many input vials and then dispense from these input vials to each vial in a selected range of output vials. For example, there could be 3 solutions of internal standard mixes which you want to dispense to all your output autosampler vials. For this task, the number of input vials does not need to match the number of output vials. The makeup to volume task makes the allocated container up to a defined volume. The actual makeup volume does not need to be defined, only the target makeup volume. The software will work out the volume that needs to be added by calculating the volume already in the container. The 50ml jar accessory rack is very handy to use for this task. This task is often used as the final step of sample or standard preparation in an autosampler vial. We shall now have a look at tasks which are used for sample preparation. For the Aliquot Sample task, a defined volume is taken from a series of input sample tubes and dispensed into an equal number of output tubes. The same volume existing in the input tube doesn't need to be defined, and if this is left zero, the workflow would still proceed. This is not the case with the other tasks. The reason for this is with the Aliquot Sample task, in the original containers containing the sample, there might be different volumes in each of the containers. For example, if they've just come straight from the field. You will notice that the location of the input tubes for this task is slightly offset from the other input tubes for this reason. The Add Surrogate task adds a defined volume of a surrogate standard solution from a single input vial or vial group to a series of output vials. A surrogate is normally added at the start of the sample preparation workflow, and then the recovery of the surrogate calculated. The target analyte concentration might be adjusted based on the surrogate recovery, or there might be an acceptable range for surrogate recovery, for example 80 to 120%. And if the recoveries are in this range, there would be no concentration adjustment. Therefore, the surrogate solution would usually be added to the samples in a larger container before filtering or any other sample cleanup steps. The AddReagent task adds a reagent from a single input vial or vial group to a series of output vials. The AddReagent and React task adds a defined reagent volume from a single input vial or vial group to a series of output vials and provides a time counter for controlling reaction time after the reagent has been added. This task could be used for any derivatization procedure where the reaction takes time before proceeding to the next task. Also, the workflow could be used in conjunction with the Eprep heater cooler accessory, and then the temperature of the reaction could be controlled as well as the reaction time. In the next section, we will have a look at ways we can mix the contents of a container. The syringe mix task achieves efficient mixing of vial contents by aspirating the contents into a syringe and redispensing back into the vial. The high velocity of the fluid achieved in the needle will cause good turbulence in both the needle, barrel, and the vial. The two main parameters for this task are the syringe mix volume and syringe mix cycles, both self-explanatory. When using syringe mixing, be aware that the volume remaining in the syringe needle from the last dispense will be added to the dispense volume, and this needs to be considered in doing accurate work. After syringe mixing, the syringe should be washed and primed before the next task. The needle volume by syringe type are for the 100 and 1000 microliter syringes, the needle volume is 4.2 microliters, and for the 10 ml syringe, the needle volume is 10.1 microliters. Syringe mixing is a very efficient method of mixing when the selected syringe mix volume is at least 30% of the vial content volume. For example, if you have made the volume up to 1 ml, you could set the syringe mix volume to half a ml using a 1000 microliter syringe. The vortex mixer is an Eprep accessory which can be used for most container racks. The task associated with the mixer is the shake task, and in this example I have added the shake task to a task group after the make up to volume task. So all the autosampler vials will be shaken and mixed after all solutions have been added. There are two main parameters, and these are the vortex mix time and the vortex speed. Here you can see we have set a shake time of 20 seconds at a speed of 1000 RPM. The vortex mixer is a very handy accessory, and here we can see it in action, shaking a rack containing autosampler vials after all the solutions have been added. The autosampler rack is now ready to be transferred to the instrument. A summary of all the tasks we have covered can be seen here in this table. Hopefully when creating your workflow, you will now be able to see which of these tasks is suitable for your particular application. So thanks for giving me your time, and I'll see you next time.